So Chris and I here tackled integrating the Nexys 2 board with the PIC24. We actually use the DS PIC24 chip, which is apparently the PIC24 with DSP capabilities, not that we actually use them. We'll get next slide. So the basic requirements for this is take the Nexys 2 board and accept input using a PS2 keyboard. Once you get a complete set of data, up to 255 characters or terminated by a return key, send that across to the PIC24 over UART and what the UART does is calculates a CRC16 checksum, which is a 16-bit checksum, so you get a short. And then once the UART or PIC calculates that, send it back across to the Nexys 2 over the same UART connection, and finally display it on the Nexys 2's LCD.
Alright, so this is our block diagram for things connected, mainly in the Nexys 2. We've got the PIC24 over there connected via UART. The keyboard, although I wasn't very clever at so it didn't come to me to think to hook that up via UART, but I found a third-party PS2 controller and interfaced that with GPIO. And there are two there because I had some trouble handling both the input and output on the same GPIO. So that's kind of a hack, I guess. You've got the LCD there, of course. I've seen that a lot. LEDs, mainly for debugging and just some, for seeing what's in certain registers, etc. And buses and the standard stuff. Keyboards that scan DAB there is hooked up to the interrupt controller. Scan DAB is a signal out from the PS2 controller, and that asserts itself when there is valid data coming out of the PS2 controller. So when I handle that, I basically pull that out, copy it into a buffer, and then tell it that I've done it right, and then it's good to get the next data.
Hold on a second. A couple other interesting notes about the bridge here between Nexys 2 and the PIC24. We were originally going to go through the RS232 plug on the Nexys 2 board, but the PIC24 demo board actually expects the UART to go out through USB, and it does its own conversion. And for example, if you're going to talk with Windows, you'd install a driver. So what you can do though is the board has a series of 20 or so pins, and 2 of those are actually the RX and TX pins. So we remap the UART from the RS232 port to one of the side bays on the Nexys 2 and just connect it with wires over to the PIC24. And we're also drawing our power for the PIC24 off of the Nexys board.
Like I said, I have a buffer for taking the scan codes during the interrupt handler, and put those into a buffer, and then basically continue on doing whatever I was doing. I've got a main loop that basically cycles through those scan codes and filters out what key was just entered. Does some does a lookup table to find out what key it was, and then puts that key into another buffer to be output to the UART. That's basically what all this is here. So you've got some initialization stuff here, enabling interrupts. Check the buffer, check the scan buffer, check the buffer that the interrupt puts stuff into. I've got a flag that is set if enter is hit. Enter is pretty much the key that triggers triggers the send. If the buffer to be sent is full, the LCD screen will display a message saying it's full and prompting the user to hit the enter key to go ahead and send that over to the PIC24.
Should also note that the return key actually isn't sent across, so only the keys before you press return actually get sent. The PIC24 side is a bit simpler. The first thing you do is you initialize the oscillator inside the PIC24, so you can change the frequency of the oscillator in code, which is interesting. there's two different, a pre-gain essentially and a post, and they have documentation saying the calculation that you use, and you set these two values, and it sets an internal frequency based off that. So after that, we initialize the UART, and then the PIC24 just starts spinning and waiting for a count. We send across the count as 1 byte, hence the 255 character limit. It's convenient to send across. Once the PIC receives the count, it's echoed back, which the idea there being if the PIC had to initialize any internal data structures, it could do all that before it responded. And then once Nexys 2 gets the count back, it actually checks if they're the same. We'll report an error if there's not. But if it's successful, it begins sending across. And it'll send all the characters in one go. The PIC receives them all, calculates the CRC16, which is basically a repeated call to a calculate function over and over again. Finally, converts the short into 4 chars and sends each one of those back across. And the Nexys 2 simply has to display each character as it receives them. So finally, for our testing, we separated this out. Each of us, I focused on the PIC, he focused on the Nexys 2, and that provided a nice clean break for work because the only communication was over the UART. So once we agreed on the protocol there, each could work on their code base separately. For the PIC24, the CRC16 calculations were all unit tested. Those were written separately and then integrated in after I was happy with those. And the system level UART testing is performed using the UART capability of the PIC2. The PIC2 actually, I found out, not only does it program the demo board, you can use it as a logic analyzer, a makeshift oscilloscope, and a UART. So I was really surprised at everything it could do, and really happy with it once I found out everything it could.
Okay, some of the testing, or how we got started on this, was we first wanted to make sure we could get some sort of communication between the boards over the UART before we moved on to the rest of the project. So we basically sent a test signal over, and we just wanted to get some sort of acknowledgement that there was something being sent. So that was our first milestone, I suppose. Then as far as testing the UART, found that tying the TX back into the RX line actually helped a lot with testing that, not having to have another device out there. Later I got a hold of a USB to, or RS-232 to USB, serial to USB converter, so I hooked that up to the PC and I can actually see that output on the terminal. And that was actually kind of exciting to see. As far as the PS2 controller is concerned, I found a VHDL implementation on that online. And I interfaced that using a GPIO. Actually, 2 GPIOs, but anyways, some of this stuff was, first off, I wanted to make sure that I was getting into the interrupt controller. That was my first milestone for that there. Once I got that, I knew that, like, okay, I'm getting here, okay, am I getting the right scan codes? Am I entering the keys here? So after that, testing the scan codes, and then go ahead and making sure I'm getting decoding the scan codes correctly. And
Final step was hook it all up and make sure it works. One final thing I'll say with testing the PIC24, one nice thing was it being a hardcore microcontroller is you can actually use the IDE software and set breakpoints and debug through. But one problem I ran into when the board was on debug mode is I could talk to the Nexys 2 over UART, but the PIC couldn't get anything back from the Nexys 2. I'm still not sure why, so if anyone figures that out, I'd like to know. But it runs fine in release mode essentially, not debug. So I don't know if the voltage is too high, drawing power from the PIC kit 2, or what the issue is. I wasn't able to figure it out. So head over here, there's bench 2 for demo. That's the awesome wiring.
We've got the LCD screen hooked up there. We've got the PIC2. These are the transmit and TX and RX lines, and this is just supplying power to the
PIC24. And
So anyone feel free to hit some keys.
and yeah, you can see as the keys show up there, and if I keep going, the LCD will basically clear and continue adding stuff. That's not clearing the buffer, that's just continuing the display of the data.
So you hit enter, and it goes across, and you get the CRC16 back.
So
So
this
if
is
you
the
pull up for an example,
verification here.
a classic
So-
one is 1, 2, 3, 4, 5, 6, 7, 8, 9.
Alright, so
Should be.
get BB3D.
Mind
Yeah,
you,
which
there's
is-
multiple ways of actually calculating the CRC16. The one we went with matches just the base CRC16. I forget what it's actually called, but we get BB3D.
One other thing of note is for the keyboard, to simplify the reading of the keys and to negate the auto repeat, we only read the key sequence after reading a scan code of F0,
Okay.
which
After the
it
break.
basically reads only when you pull up the key, which simplifies it a bit. That only, yeah, but that's our project.